Okay, just to check, we are on live. Hi everyone, we are back in the afternoon slot. So if you could able to hear our voice, just keep in the chat bot that we are good to start. Okay, people are joining. Good afternoon. Good afternoon,
Let's
Vamshi.
wait for
Yeah,
1 2 minutes so everyone will be back.
yes. The
Then we will start.
yep, live count is increasing. I believe morning hours you have got some very good learnings from the previous speakers, and let's keep the same momentum. So we have more interesting sessions on the way. Now in the session 4, we are in 5, 6. So all the sessions are much more interesting. Okay, cool. Can anyone type what are all the sessions we covered since morning? Like what are the 3 sessions? Just keep it in the chat so that meanwhile others are joining the call. Okay, Kanchan, you are very active. Iniad, Durga, Vamsi Kishore, Shirisha Gaud, Varma, everyone, I think you are on track in attending all the sessions.
Just I also saw these people from morning. Okay, they are continuously joining the session back to back.
Yeah, that's good. Okay, okay, Pankaj. So, yep, let's start with the session. So, good afternoon, everyone. So, we are back in the afternoon. So, we have our next speaker, Mr. Pankaj. He is a Microsoft super user and 6x Microsoft certified. I think you could find him on LinkedIn. He's close with 60,000 followers on LinkedIn. He's keep on posting a lot of stuff, good stuff related to analytics field. So to check out his profile, if you wanted to connect with him, you can connect with him on LinkedIn. I'll share the LinkedIn profile in our groups as well. So today we're gonna learn one more interesting topic, and the core topic with respect to your interviews and with respect to this PL300 certification cracking part, which is data modeling. So thank you, Pankaj, for accepting our invitation, and the stage is all yours.
Okay, first of all, thanks Bharat for inviting me for this particular session. I will start with my introduction. I am Pankaj Namekar, having 6+ year corporate experience. Throughout this journey, I mainly work with Power BI, SQL databases, learning Fabric now. I'm 6x Microsoft certified, PL300, DP600, and other certification related to Azure. I'm currently working in Power BI from last 6 years. So today we'll discuss one of the very important topic for your better analysis or better reporting, that is data modeling in Power BI. So I will share this presentation after the complete session if anyone want to need this. Okay, so let's get started with today agenda. If anyone have any question, they can continuously keep in chat. Okay, so I will address or Bharat will address. I will take that question in between also, so no need to wait for at the end. Okay, for Q&A session, if you have any question, just ping in the chat, that will be taken care. Okay, so today we'll discuss in brief what is data modeling, then importance of good data model, star versus snowflake schema, data preparation basics, then relationship type, cardinality and cross filter direction, fact versus dimension, common mistake that data analyst or BI developer is making during the data modeling step, that we will see, and that's how to build a scalable data model for your optimization of the model, as well as with that you have to minimize your DAX code. Okay, if you have set up a good model, then maybe you can get your insight with a simple calculation. No need to write a lengthy code or very complicated logic. But your model is not set up correctly, then you have to struggle with your calculation. Then best practices and real example for the good data modeling. Okay, so this session will be for basic to intermediate level. So we'll cover the basic things in detail, and I will show some demo how to build the star schema model, Snowflake schema model in Power BI with the sample data, and what is their advantages, disadvantages, like pros and cons. Okay, so depend on the scenario, we have to select the model type. It is not that this model is bad or this is good. Depend on your environment, depend on your backend data sources, you have to go with that particular choice. So let's get started with the introduction of data modeling. Okay, so what is data modeling? Let's say your data is updated on in a single table on daily basis. Your business is generating lots of data. Let's say 500k, 1 million row that is generated on daily basis. Let's say you're working for Amazon, Flipkart, and on daily basis, multiple users are punching their order. So that order data is saved somewhere, either in a database, big data, data warehouse, somewhere that is saved. If you are using to store data single table, that size will be very high. And if you are connecting directly with that particular data for your analytical purpose or any other reporting purpose, then it is very difficult to get your data insight on time, because there will be huge performance issue. Because let's say now I am the customer from Amazon, my details will not change. Only thing is that I can order a multiple product. So product ID will change. Let's say date will change. Today I order something. In next day I order something. My details will remain same. My address, my phone number, email ID. So those are the dimension. So what will change on every order? My order quantity will change. My price will change. My total billing will change. So that's how the model is structured. So there should be some dimension and fact, and whenever there is a need to perform any analytics, we should connect to the model, and we should create our reporting dashboard, or even we can extract the data for particular time frame using this particular concept. So this is how model is used for getting better insight with a faster. Okay, so it is a foundation for accurate reports. With respect to Power BI, it will help for efficient DAX calculation. So data modeling concept is not limited to Power BI only. If you are the Tableau user or like QSense user, or even you are just exporting data into the Excel from any database, there also it will play the important role. Okay. Then again, if you have good model, you will get accurate data. Performance will be better, and for DAX, it will be easy to make a calculations for time maintenance calculation, or if you are calculating some variance analysis. Multiple frame analysis can be done using a simple calculation if you have the good model design. Okay, then data modeling architecture in Power BI. If you see the flow of Power BI, how the end-to-end process is done. So we are connecting to the data sources. Then Power Query is used for ETL purpose, like extract, transform, and load. Finally, we will load the data to the model, means Power Pivot model. There we are building our model, either star schema, Snowflake schema. And then after that, we have to write a DAX code to get our insight generated, and then we are presenting through visual. So this is how we end-to-end process is there. Okay, so model is playing very crucial role in this particular process. Of course, there is a after visualization, we can set up a role level security, we can publish to the Power BI services, we can create apps. That is related to sharing and collaboration. For before creating any report, these are the basic step, and here model is one of the key step in this particular process. So if you have good model, then other process can be simpler. Okay, for creating a DAX calculation, and even for visual level also you can create a better visuals and for reporting purpose. So data sources, we can use a multiple data sources. Power Query, I will not cover that. Then model, in model what we are doing, basically we are pulling the different table, like fact table, dimension table. We are connecting those table based on the keys, like usually dimension table I have primary key, fact table I have foreign key. Let's assume your customer is one dimension, and in fact we have sales data. Okay, one customer can purchase multiple times, but the customer details will remain same. In customer table you have unique customer ID for each customer, so that will become the primary key. In fact sales, one customer can buy multiple times like that. So that will become your foreign key. So we can connect fact dimension by using this key, primary key and foreign key. If you are the SQL, if you are know about the SQL, then you should familiar with this primary key, foreign key, then composite key, unique key. These are the keys. Whenever we have to work with a multiple table to get our desired output, we have to work with the joins, and to join the table, we need the keys. In short, common column is between the different tables. Then what is a fact and dimension? If you see any model, then there are mainly two types of table: fact table and dimension table. Okay, fact tables are nothing but they will store the numeric data or fact about the business. Let's say you are running the e-commerce store. Okay, now you are getting the revenue from the client. You the in that particular revenue, how it will be captured. You will capture how many quantities order, what is an unit price, what is the amount order value. Okay, this related to the fact means these are the numerical data in your table. And what is the dimension? Let's assume that that particular order is punched by any customer. So that is from any store, that is from any city, location. Those are your dimension. Now, if you just have the numeric data, you will just see the number 1 million. Now, the thing is that if you want to do analysis of 1 million revenue, then you have to track against your country, city, or customer. Then you able to see that particular 1 million breakup. Like this 1 million is by country. Let's say we have 5 countries, then how 1 million revenue is break out through these different countries. So then we are able to find that okay, India is the top revenue generating country. Same with respect to store or customer, who is the top customer, from that we are getting more revenue. So to do analysis, we should have to interact with the both fact and dimension table. Even you have just dimension table, let's say you have only customer details. So if you just you cannot just take a customer details name. Okay, so if you just drag the customer details in Power BI and you don't have any numerical columns, assume that you don't have any revenue quantity, then you will just able to see the text data like we have the 100 customer and these are the details of those customer. To analyze the revenue for each customer, to analyze the units sold for each customer with respect to city, the region, country, we need the fact. So if we drag the facts against the dimension, then we'll see some insight. We can analyze the patterns, then trends. Let's say we have calendar table, that is one our dimension table. If you want to find the trend of sales, then you cannot just drag 1 million sales. You will not able to analyze anything. But if you drag that 1 million sales against the year, then you will see in 2025 we have less sale. In 24 it was better for same period than what is affecting for the current year. To do that particular analysis, which you should get involved in both fact and dimension table. And how it will be done using modeling concept. If this table are connected with each other, then only you are able to do that particular analysis. Okay, then there are mainly two types of model. Okay, star schema model and snowflake schema. Okay, so just the information about the star schema. Okay, fact table, you can say sales, order detail, inventory, transaction. These are the fact table. Dimension table will be product, customer, date, or if we have the calendar table, that will be one dimension. Then geography. Okay, if we connect this table, then those are into one model. Okay, now star schema, how it is known as star schema, because our every dimension table is directly connected with our fact table. Okay, here you can say we have different dimension table: dim employee, dim products, dim time, dim store, dim cell type, and fact sales is there. Every dimension is directly connected with the fact table. Now what is the advantages of star schema? Okay, the model structure is simple, and if you do any filtration, or if you, let's say I want to see revenue by employee, only one level filtration will happen. Employee will filter to the fact cell. Let's say I want to calculate the revenue by employee, I will drag in table. In most of the cases, people are utilizing the star schema model in a real time project, but in few scenario, if the backend data is not optimized for star schema, then you may go with the snowflake schema. Okay, if you are working with a very huge data, then Snowflake is into the next normalization form. Okay, this is the, let's say, first normalization form. And if you go to the Snowflake schema, then you will see, let's say, product have another table called subcategory, then category, like single dimension table have the multiple related dimension table. Okay, that is a Snowflake structure. So we'll see in upcoming slide. The advantages of star schema is simplicity, clarity, DAX optimization. So with a simple DAX calculation, so we get a better insight using a star schema. Then maintenance is easier. Full competitive works best with the Power BI. Like Power BI is designed for star schema. If you go to the Microsoft documentation, they will always recommend you go with the star schema. But now in some scenario that is not possible, then that also work. You can go with the Snowflake schema also. It is not that if you model is not into star schema structure, then Power BI will not help you. Okay, that option is also available to go with the Snowflake schema. Only thing is that it is recommended by Microsoft, or if you see anywhere in the blog, it is recommended that star schema should be preferred over the Snowflake schema because it has a better advantages in terms of performance, simplicity, and simple model structure. Okay, here whenever we are writing any DAX query, it will be faster as compared to the Snowflake schema because only one level filtration will happen in star schema. Better comparison ratio in Vertipack engine. So in Power Pivot, backend of the Power Pivot is Vertipack engine. If you are using the external to like DAX Studio, then tabular editor, then you will compare these particular things in with respect to the performance for model, then column level DAX. But in Power BI, it is not directly visible. You can use performance analyzer in Power BI, but if you want detail analysis, then you have to go with a tabular editor DAX Studio, okay, to get a detailed performance of each DAX code or each major calculation, calculated table, okay. Then you have to go for external tool. Again, it is optimizing the memory filter propagation, okay. So single level filtration will happen here in this case. So it is very straightforward, okay. No multiple level filtration will happen. So this all information related to star schema, we will go for Snowflake schema. The definition of Snowflake schema, okay, an extension of star schema where dimension table are normalized into multiple related table, okay. So assume that star schema is into first normalization, then Snowflake will be into second, third, or fourth normalization, depend on the your how your dimension table is breaked, okay. Let's say you have product table, then that can be break into product category, product subcategory, then brand, okay, like that. We can categorize that into multiple buckets. So this is how first normalization, second normalization will be done in Snowflake schema. It will be very detailed. Okay, if you see the diagram of Snowflake schema, here you can see we have product dimension. Okay, sales is connected with the product dimension, and product dimension is connected with the category dimension. So we have another. Let's focus on the product dimension. Okay, product dimension connect with the fact cell directly. If you ignore all this blue table, like the blue square, then again this will be your star schema model. Okay, Snowflake is nothing but the extension of star schema. Okay, just give me a minute. Okay, so here product dimension is again break into two different table: category dimension, brand dimension. Okay, again if you have subcategory, then category will be connected with a subcategory. Now if you want to analyze sales by or revenue by subcategory, then how filtration will happen? Let's assume this is our category table, then product dimension and sales table. Okay, this connected with the product, and product table connected with the sales fact table. Okay, I want to analyze my revenue by category, then how filtration will happen? Our category table will filter the product table, then product table will filter the fact table, then we will get a insight like revenue by category. So two level filtration will happen here. So as compared to the star schema, the performance will be less because multiple level filtration will be happen. Now in this case we have only up to the second filter. Okay, there may be chance in real scenario you have another one table here, that is subcategory. Okay, and then third level filtration will have subcategory will filter category, category will filter the product, and finally you will get the sales by subcategory. So this particular structure will make your model performance slow. But if you are working with a very huge data, okay, then in that case, or you are not able to convert your model into star schema, you can also go with a Snowflake schema. Okay, it is not that you have to go with a star schema every time. Depend on your environment, depend on your scenario or business logic, you have to choose the schema. Okay, so here pros and cons are here. Okay, reduce data redundancy, then complex join, slower query performance, difficult DAX expression. Ultimately, it has to filter multiple tables to get your desired output, so performance will be slow as compared to the star schema. Okay, but whenever you have some hierarchical data, okay, let's say category product is break into category, categories break into subcategory. Okay, in that case, this may work good for you. Okay, now again, it's depend on the scenario, how the business logic is there, or depending on your environment. Okay, you can use the SAS schemas and Snowflake schema. Okay, if you are with a good experience, then you can sort your Snowflake schema better with respect to the beginner or the, let's say, the developer who has the 1 2 year experience. Okay, because to work with a Snowflake schema, you should have the good understanding about the data modeling, how the filter will work, okay, how propagation of filter will work in Power BI. If you are working with a row level security, then how the filtration will done. If you have many to many relationship with a Snowflake schema, then it will be very difficult to achieve the desired logic. Okay, you have to write a complex DAX. Maybe you have to work with some disconnected table. You have to use a use relationship function like that. Okay, so complex calculation will be involved. So if you are the beginner or 1 2 year experience, then try to prepare the star schema for your model. Here is the detailed comparison of the stars and Snowflake schema. Okay, in terms of performance, star schema is faster, simple joins, and better comparison. If you see the star schema model, we have only one join between fact and dimension table, like single level filtration will happen. Here, multiple level joins are there. Okay, so whenever we are writing any DAX code, that may be slower. Even without any DAX, if we are just utilizing the slicer for filter our data, that may impact the on performance because multiple level filtration will happen. Okay, here multiple table travelers. So here we have only one dimension and one fact. In between, we have to travel. Like if you want to get a insight from that particular dimension with respect to your fact. Simplicity, the model structure is simple for star schema. This is a complex model, simple to navigate, difficult to navigate, clear structure, require expertise. Okay, so in order to work with a Snowflake schema, you should have the detailed knowledge of data warehousing concept or detailed knowledge of how to build a Snowflake schema, what are the different factors that are affecting on a performance of the Power BI model. You should have the good understanding of that particular details. Okay, then only you will able to work with a Snowflake schema to get your desired output. It is not that if you have the knowledge, then only you can work. Depend on the scenario again. Okay. DAX, simple calculation, better measure performance, less complex formula. So I already explained that. If you have SAS schema, you have to write a simple DAX calculation to get your desired output. But if you are working with a Snowflake schema, for the same output, you may write a complicated DAX code like use relationship function, and there may be chance you will face the performance issue. Scalability, okay, it will consume the more space, handle most business needs, easier to maintain. Okay, this is the advantage of SAS schema. Snowflake schema will have the less storage space because if you see the structure, our product table is again break into category and brand dimension. Okay, so this if you only if you want the information related to category, then only you will use this particular table. Else, in a star schema, this product dimension will have the category information, then brand dimension. The size of this particular table will goes on increasing. This is into the next normalization form. So here it will consume the less space as compared to the star schema. Now we will jump to relationship in Power BI. Before that, I will quickly show you how to create a star schema or Snowflake schema in Power BI. Okay, just let me open. Okay, before that, I will show you in Excel just how in real. So this is a flat table. Okay, there is no model concept here. Okay, on daily basis, if we are generating 1 million entries, then same will be pulled in this particular table. There will be no any second table. So this will degrade the performance, and we cannot use this data for our any analysis, even for reporting purpose. So that's why modeling concept is there. If you go to star schema here, you can see we have multiple dimension table and one fact table surrounded by dimension. So this is called as a star schema because your every dimension is directly connected with your fact table. Okay, even you can see customer key. In fact, we have customer key in product. We have product key same present in product key. Dates, we have date key in our fact. For dim store, we have store key has a key, and same is present in our fact table. Means fact table usually contain the keys and numeric data. Here you can see all key, store key, customer key, product key, date key, sales ID, and we have only numerical data called quantity, sales amount. Okay, but dimension contain the keys like mostly primary key and with the attributes. Okay, customer name is one attribute, gender is one attribute, city is one attribute, like store also name, region, dates. We have multiple attributes: year, month, quarter, week of the day, month, year, quarter, like that. Okay, in product also we have product name, category, price. Okay, so these are the information related to product. So this is how star schema looks like. Okay, in short, your every dimension is directly connected with the fact table. That is the known as a star schema. Even if you have only these two table, then you can also call it as a star schema. It is not that you should have only four table and one fact table surrounded, then only it will be star schema. That is not the case. Okay, even in your model you will have the more than one fact table. That is also scenario. In Snowflake schema, if you ignore this table, then again this is star schema, and extension of star schema is nothing Snowflake schema. So we have added one more dimension called dim category. So we have products here. I just added one more table called category. So product table will be connected to the category table, and then category will be connected to the fact sales. If you want to analyze the sales by category, then category will filter to product and product will filter to sales. So multiple level filtration will happen in Snowflake schema. In real, there may be chance you again have one more table called subcategory here. Okay. If you have that particular table, then how it will be subcategory will filter the category will filter the products, and product will filter the sales table. So multiple level filtration will happen in with with respect to Snowflake schema. So these are the basic information about the star schema, Snowflake schema. We already seen the diagram and also the real table. So I will just connect this table in Power BI to show you. So I open the Power BI. Hope everyone is aware about the Power BI desktop. I will just connect to the Excel modeling. So here is a file called star schema. Okay. So in that I have 4 to 5 tables. So we have customer dates, fact, sales, products, and store. Okay. These are the table. I will click on OK. Okay. So these are the file. I will just load to the model. Okay, go to the model view. Then since auto detect relationship is enabled, Power BI has detected the relationship automatically. But in real scenario, if that is enabled for you, you should at least validate the relationship for every table. If someone in a backend team has renamed some column or provided the wrong column name, let's say product name column, they have provided the name to product key. Okay, so Power BI how relationship will be detected based on the common column name. Okay, even in your product name you are putting the product key, then that will be not treated as a product key, that will be considered as a product name for relationship, like that. So you should always validate the relationship. Even auto detect is enabled for you. Okay, in real project, like I'm not using this auto detect option, but this is my personal laptop, so Here that is enable. So here you can see product key is connected with the product key in both the tables. So fact, sales, product. So similarly, I can validate the relationship for customer. Customer key is connected with the customer key. Date she is connected with the date key, and we have last store should be connected with the stores key. Okay. So this model will be into star schema because the criteria is your every dimension should have direct connection with your fact table. Now you can see all our dimension table, date, store, product, and customer are directly connected with the fact table. So this is called star schema. Okay. Even if you have only one table, let's say I have only fact, sales, and product table. Okay. Now if this particular two tables are connected, then also you can call the star schema. Okay. Whenever you have only one table, then that is called a flat table. Okay. There is no any model. So this is a flat table. You have more than one table, so you are into modeling concept, and then you have to decide into which model, star schema model or Snowflake schema. So here we are connected with a star schema model. There may be chance in real, you may have more than one fact table, you may have more than four dimension table, like that. Okay. In real time you have 20 dimension, two fact, that also falls under star schema if your all dimension is directly connected with your fact table. Okay. Again, we will take another example for Snowflake schema. I will just pull all the file for Snowflake schema. Okay. In real project, maybe your data is not into Excel, that will be into database or cloud. But just for explaining, I just put into Excel, so it will be simple for connecting and to quickly show everyone, okay, how the schema will look like into Power BI. Okay, so we have around 7 8 tables: dim customer, dim date, geography, products, product category, subcategory, dim region, fact, sales, dim store. Okay, so these are the table. I will load to the model. Again, auto detect relationship is enable, so it should detect the relationship. Here you can see all our table is connected. I
Pankaj,
will
can you
just
show n for any one of the table by deleting the relationship? Like people are asking if it is not auto detected, how can we, just by
okay,
dragging and dropping.
sure. So I will delete this relationship between fact and date dimension. Okay, here you can see no relationship. Let me just organize this properly so everyone will be easily understand this. Okay, so product dimension is connected with a subcategory. Subcategory is connected with a category. There is only one table called date that is not connected to how to create a relationship. Now here we have a date key. Here also we have date key. So we can drag from dimension to fact to connect. Okay. Now once you drag, it will pop up this particular window. Here you will see the preview of your data. Okay, date column contain the 1 2 3 number. Here also you will able to see the number. So and here it is showing the in which cardinality you want to connect. Like there are four. Okay, many to one, one to one, one to many, and many to many. By default, it will detect automatically correct. Okay, so we'll see what are the different cardinality and their use. Just for showing, I will explain this particular window. Okay, so here first table, second table, and how this table we want to connect based on the which column key. So we are selecting date key from both the table. Automatically it has detected one to many, make this relationship active. So if you have more than one relationship, then you have to worry about this particular um, checkbox. Okay, let's say in your model you have order date and delivery date in your fact, and then based on which particular date you want to make this relationship active. Either order date relationship should be active or delivery date. Okay. So there you need to worry it. But if you are working with a single date, then by default it will be active only. So I have selected. Now our date dimension is connected with your fact table and the relationship is one to many. So here you can see one side, here asterisk means many side. So this is how Snowflake schema will look like. Okay. So if I want to filter the category, then category will filter the subcategory table, subcategory will filter the product table, and product table will filter the sales table like that. Okay. Simply I am just dragging the two column. Let's say category. Here we have limited data, so we'll get an insight very easily. Okay. Let's say I'm from fact table. I want to calculate sales amount. Okay. So here sales amount by category we are getting, but actually how filtration will happen. Your category will table filter the subcategory, subcategory will filter the dim product, and dim product will filter the fact table, and finally you will get this particular result. So three level filtration will happen here. But if we have star schema, let's assume we have dim product and fact sales, only two table, then it will be only one level filtration. Okay. Dim product can directly filter to fact sales. There is no any in between filter. So this will be very faster as compared to the Snowflake structure. Similarly, for region, if I want to get a sales by region will filter the store, and then finally store will filter the fact sale. So multiple level filtration will happen. Now, how to convert Snowflake schema into star schema? Okay, if these two tables are connected, means there is key between these two table. Okay, so using merge option, you can join this table in Power Query, and dim geography details you can pull to the dim customer. Then this table you can eliminate in Power Query. Like no need to load to Power Pivot. Let's I will show you one example shortly. Okay, let's say we have dim geography connected with a dim customer. Okay, both have the geography id. Here is also geography id. Okay? So I can pull the geography detail in customer. Okay, using merge option. Okay, I want to merge customer with a geography. Okay, what is the common key between this geography id? Okay, by default I will select the left outer join. I need all the customer detail. Whenever geography detail is there, then pull those record. Okay, left outer join. I will just expand this. I need only country, state, city. No need of geography ID because that is already present in customer table. So now geography details are pulled into customer table. So no need to load this table into Power Pivot. So I will disable the load. Okay. And now if you see here, so geography table will be eliminated because that information we already pull into dim customer. Okay. If I close and apply, the geography table will be not. That table will be limited to Power Query. If you have added some detail into geography table, automatically that detail will be added to customer table because these two tables are joined. Okay. Similarly, you can convert dim region to store product category. You can put the subcategory and subcategory to the product. Again, this is a one way. Okay. Depending on your business logic, you have to decide these things. Okay. Then there is a auto detect option. Okay. Auto detect the relationship. I will show you how to disable that. Data load, auto detect new relationship after data loaded. Okay, if you disable this option, Power BI will not detect the relationship automatically. Okay, in your real project you should disable this option. Okay, because if you are working with a 2 3 table, that is fine, but you are working with a 20 table, 30 table, then again manually you will validate. So instead of that, you can create a relationship for each table with your understanding. That will be the better approach. Next, jump into the cardinality. Okay, so we have mainly four types: one to many, many to one, many to many, and many to one also. Okay, we'll take a same example here. If you see any two table, let's say I'm dragging the fact table and dim store. Okay, so these two tables are connected by one to many relationship. Okay, one means one is visible here. Okay, that is called, and asterisk means many sides. So this relationship is called one to many, and filter direction will be always from fact to dimension. Okay, whenever you have made it to many relationship, in that case you can keep filter direction in both the side. Okay, like both side, filter from fact to dimension, also dimension to filter. So this will be ideal in many to many relationship. Okay, but again you should avoid the many to many relationship. That is also one important concept. But by default, if you are working with a one to many, many to one, and one-to-one relationship, filter will be always from one direction. Okay, always from fact dimension to fact. So this arrow is showing. So we will filter, our data will be filtered by this dim store table to fact sales table. Okay, this is one to many. If you are deleting this relationship, now how this was created, I have dragged this sales store ID to fact store ID. Okay, that's why it was one to many. If I drag reversely here, it will be many to one now. Okay, but filter direction will still remain same. So many to one and one to many is just reverse. Okay, how we are, if we are dragging from dimension to fact, this will be one to many. If we are dragging from many to means sales, fact sales to dim store, it will be many to one. Many to many side is means in both the table we have duplicates the record. In both table we have duplication. In short, foreign key is present in both the table. In that case, it will be many to many side. Okay. Let me pull that data quickly. Assume that you have region table. In region, the your ID is main key is country ID. Okay, and you have fact table. There also country ID is present. But under region or under country, you have state city details. So for in India state, the India code will be repeated multi-time. So if you connect country code from your country dimension to the fact country code, it will be many to many site. Okay, why many to many? Because one country can contain the multiple state. Even one state can contain the multiple city. Okay, to avoid this, you have to create a separate country table that contain the unique country name and unique country code name. Okay, so here, if I think it is not detected correctly, columns headers are not detected. I will just use first row as a header, first row as header. Okay, for this. Okay, fine. Product ID, and then this is customer ID. Okay, so here you can see in our customer dimension table, customer IDs are repeated. That's why it is showing many to many. If I try to say many to one, it will not allow. If I try to convert it into many to one, it will not allow. By default, it is detecting the correct relationship. Okay, if you want to avoid many to many, then you have to remove the duplication from customer table. Again, that is depend on your scenario if that is allowed or not. Okay, maybe let's say some customer has changed their details in your backend, you have SCD type concept. Okay, if you are flagging what is the latest customer address, then you can filter by that particular flag instead of removing the duplicates in Power BI. So here it is many to many, and by default filter direction will be from both the table, because Power BI will be confused here from which table I need to filter which table. So it is better to keep in a both direction whenever we have many to many relationship. Okay, whenever we have one to many, many to one to one, then filter direction will be always from dimension to fact. But for many to many, it will be from both the direction. Okay. This is fine. Cross filter. Okay, so we had discussed like both direction, one role playing dimension. Again, I already explained. Let's say there are two dates in your model. Okay, delivery date and order date. So these are the role playing dimension. Okay, if you are connecting this date with your calendar table, there may be chance your end user are interested to see the revenue by delivery date and revenue by order date. So you cannot directly use that particular date. So calendar table is the ideal scenario here. Okay, so if you are using the calendar table and using user relationship function, you can calculate the your revenue by both order date and delivery date. Whenever you are selecting anything from slicer, any slicer you are adding the date from calendar, then it will filter the correct result from based on the delivery date or order date. So you may have the order date, ship date, invoice date, multiple dates. Okay, whenever in your model, if you have any single date, you should always create the calendar table. Okay, for better performance, for time intelligence, there are multiple advantages of calendar table. So we already seen merge option, how to convert Snowflake schema using merge. Okay, this other is just theoretical part. Then we should have proper data type also. Let's say in your backend, the data type is configured date and time. But in your reporting, you are not using time dimension for any analysis. And in Power BI, it has detected date and time data type. So date and time will always consume more space as compared to the data type. Okay, so if you are not using the time for any calculation, then you should always change data type for that particular column to date only. Okay, normalization, denormalization, we already seen this. Okay, now model optimization technique. Okay, in general, if you are using like select star from sales table, then you are pulling all the columns from that particular table. That is a not efficient way. Okay, in your analysis you need only 10 20 columns, so you should always select that particular columns. Okay, if you are pulling unnecessary data, that will impact on your performance. Maybe for time being it will be faster, but if the data is increase in backend, you will face the performance issue. Okay, then again in model view you can hide the this column. Now customer id column will be not utilized anywhere. Okay, so I can keep that column hidden here. Okay, in fact table, the customer key column will be not utilized. So we can, whenever key is there in your fact table, no need to keep that as a unhidden. Okay, so always hide that particular ID. So here it will be easy to see the column. If you disable view hidden, okay, then that option hide in report view, then this will be not visible in report view. Okay, now I have hidden the entire table, but you have to just hide that particular column whenever the key is present, because key we are not using for any calculation or any analysis. Okay, so keep those particular column hidden. That will be easy for your analysis, and you can navigate to the other columns easily. Okay, that is one best practice. Use numeric keys. Replace text with a key integer. Use, let's say you have some column true false, then you can change with a 0 1 like that. Okay, again if you there is scenario in your model you have day level data. Okay, like month, year, quarter and day also there, but for all your analysis you are limited to month level. No, you are not interested for any day level data, so you should always aggregate your table to reduce the data size and to have the better performance. Okay, okay, so many to many relationship, circular dependency, too many calculated columns, cross join logic. Okay, so here what happen, if you are using many to many relationship, in most of the cases it will not provide you the correct result. Okay, or maybe you have to write some complicated DAX to achieve the result. So you should always avoid the many to many relationship. So either you can remove the duplicates from your dimension table, or other way you can create another one dimension table that is called bridge table, where you will have the unique details. Means it will show the primary key and your original dimension will connected with this table, and your fact will connect with this table. So this table will act as a bridge table in between your fact and dimension. Okay, so creating too many calculated column also impact on your performance. Okay, whenever it's possible you should always go with a calculated measure instead of a columns. But there may be some scenario. Okay, and let's say you want to categorize your sales into different buckets and you need that particular buckets as a slicer. In that case calculated column will not, calculated measure will not work, because measure will always provide you the single output. Now in this scenario you want to categorize your sales high, low, medium. Okay, if you use the measure, then at a time it will either provide you the high or low or medium, but calculated column will provide you high, low, medium value in a slicer format. Okay, so in this scenario you have to go with a calculated column depending on scenario, but it is recommended that you should always go with a calculated measure. No proper date. Okay, so whenever you are working with any date calculation, you should go with a calendar table. Okay, now this is the real example of the model, star schema model. Okay, so we have internet fact, internet sales, then dim product, territory key, here dimension, dim customer. Okay, use star schema, use surrogate key. If you have duplication, then you can combine the multiple columns to get the unique key. Keep your filter always single direction, create a single date table, optimize the DAX, set correct data types, remove unnecessary column, hide and use the field. So I have explained this. Naming convention, always document the model correctly to use that particular calculation, so to use that particular logic. again and again you for your next report, or you, that in that particular report there is some change, so you can go with that. Okay. Hide foreign key. So whenever there is a key in your fact table, no need to keep that column. Okay, so you can hide them. Okay, so that's it. Okay, and then we will jump for Q&A session. So we have 5 to 10 minutes more. So I will take a question and answer.
Okay, so that's great, Pankaj. So we have plenty of questions from the audience. The
Mhm.
repetitive question is like in which scenarios we will be using this many-to-many bridge tables.
Okay, so many to many, that's what. Okay, so let's say you have country dimension and you are connected with the fact cells. Okay, in country there is a hierarchical data. Okay, hierarchical data is nothing but state is there, then city is there. In country, main key is country code, and your fact table contain the same country code. Okay, now let's say for India there are multiple states. For Maharashtra, then Tamil Nadu, Karnataka. Okay, the country code will remain same. Okay, if you connect country dimension to your fact in both the table, country code is repeated. It means both the table we have foreign key. Okay. Now to avoid this, you can create another one table, bridge table, that contain the unique country codes and unique country names. That will act as your bridge table between your original dimension table and fact table. So in this scenario, you can use the bridge table whenever you have many to many relationship. Other way, it's possible. Then let's say for customer. Okay, now for same customer ID, we have two records. Customer one have the different address, and again customer one have the different address. In your backend, how it is configured, which is the latest address, that should be considered for your analysis. In that case, you can filter by flags. Let's say flag is one. Whenever there is a one flag, then consider those as the latest customer details. Okay, then you can filter by the flag. If that is not the case, then you have scenario where you can remove the duplicates. Then you can remove the duplicates. Again, your dimension table will have the primary key. Then there is no use of a bridge table. So whenever it is not allowed to remove the duplicates and still you are working with a many-to-many relationship, then you can create a bridge table.
Okay, got it. Can you please share to the audience one slide? Can you scroll up the common mistakes we usually face in this data modeling? Above. Yeah.
Let
Yes.
me zoom
Yeah,
out.
this one only. So
Okay.
here the question is like circular dependencies. Do you have any like use case or how we can identify circular dependency and how we can avoid the circular dependency as a best practice?
Okay, so example is not there. Like we need to show real, but it is not there. The circular dependency, how this particular error will pop out. If you have created one particular calculated column, okay, assume that you have created the sales category column based on the sales amount. Let's say sales will be high, low, medium. Okay, and again you are using that calculated column for your next calculation, then there will be circular dependency. Okay, so you cannot use the calculated column again and again for your next calculation. So to avoid this, in first scenario you have created the calculated column, then you can go with a measure to write your logic. Okay, that is one way. Depending on the scenario, how your model is structured, if you are pulling the, you can say, the data from another table using related table function. Okay, and then you are trying to watch you another column in the same table, then that may be the case you will face this issue, circular dependency.
Okay. And what about this cross join logic, the fourth mistake in the
So
relationships?
cross join, again, in your both the table you have duplicates of the record, so every table will face to multiple record in the same table because the key is present in duplication from in both the table. Okay, so it will be cross join. Your single record from your first table will be connected with every record in your second table because that is also duplicated. Okay, so it will be in short cross join. To avoid that, you should always create a bridge table or to remove the duplicates. So this is purely related to many relationship. Okay, whenever you have many to many relationship, in the behind the scenes cross join will be generated in the model.
Okay. And what do you mean by this role playing dimensions? Because like we have fact table, dimension tables in the schemas. So, do you have a concept of role-playing dimensions in the modeling, like how we can best use of it and what kind of common scenarios? Yeah.
Okay. Now let's say there is
Pankaj, I think I lost you.
sorry, okay. I think I was speaking on mute.
Yeah, yeah, please go ahead.
Let's assume in your fact table you have multiple dates, okay? Order date, ship date, invoice date, and return date, okay? At a time, there will be only one active relationship, okay? If you are using directly these particular columns without calendar table, so you cannot use any slicer, okay? So if you filter by order date, maybe delivery date will not be there. Let's say we have ordered today, that delivery will be not on the same day. That delivery may be in a 5 days, 10 days, okay? The range will be different. Minimum date always will be order date, maximum date will be always, let's say, delivery date. But
Oh,
in between, if you are using any column in a slicer, that may not capture the order date. So to avoid this, what we are doing generally, we are creating the calendar table. Now one relationship will be active, other will be inactive. Let's say we have relationship active with order date and other ship date, invoice date, and return date are inactive relationship with the calendar table. Now calendar date will act as a role playing dimension here, okay? Whenever we are using the revenue for order date, we will able to see the revenue by order date. If I want to calculate for ship date, then how I will calculate, instead of making this relationship active, I will use the use relationship function, okay? So calculate total revenue user relationship, calendar date, and this date, okay? So calendar date will filter the revenue based on the ship date. So calendar date is playing the role playing dimension here, okay? So it will act as a order date, it will act as a ship date, it will act as the invoice date. So we are using only one calendar date that will providing the insight based on the return date, invoice date, ship date, and order date. So that is nothing but the role playing dimension.
amazing. Okay, so far I think most of the people have got plenty of ideology on this pure data modeling because this is one of the common scenarios you will be facing in your real-time project. Also, when you are attending this, PL 300 series of exam, you will be facing these scenarios only. So, thank you so much, Pankaj, for briefing us this wonderful session in a simplest manner. So, our audience are asking this presentation as well as the use case files what you have delivered for Snowflake and star schema conversion. I'll get the files from Pankaj. I'll be able to share to the attendees. So thank you so much, Pankaj. If you have, I think people are appreciating in the comments. It was a very wonderful session, Pankaj. Thank you so much. Looking forward for our other upcoming live sessions.
Definitely, I will be excited for next upcoming session, and thank you all for your time for this session. You can connect with me on LinkedIn anytime. I will happy to
Yeah, guys, when you
help
get
anyone.
time,
Okay.
just check Pankaj LinkedIn. He posts good content related to this Power BI data modeling. He also started Fabric series. Just have a look into his LinkedIn post. So I think now we are moving to the next session, guys, from Amit Chandak. So session 5, you can join that link, live link. I'm ending this live. So thank you, Pankaj.
Thank you all. Bye.
Yeah, hi Bharat.